Hi, this is Seung, and I'm the Principal and Director of Sky Academy, and we've come to our final lesson on further trig ratios, the end of this topic, and I want to conclude by doing a broad summary of everything that we've learnt in this unit of work, in this topic. And so I've put it all up on the board and I've named it Summary of Further Trig Ratios. Let me go through what we've done up until now. We looked at the unit circle. And we worked out that the unit circle was x squared plus y squared equals to 1. And on the unit circle, we've been able to redefine our angle theta for trig ratios as follows. To let the angle theta be the angle that a point P, x, y makes with the positive x arm as measured in an anti-clockwise direction. So in other words, if you were to have a point P, x, y, it is the angle that this line makes with the origin and the positive x arm. It's that angle measured in an anti-clockwise direction that we're interested in, and that will give us the ability to work out the trig ratio sine, cos and tan for any angle greater than 90 degrees. In fact, any angle whatsoever of any size. Alright? And we've worked out that there are some basic facts about the angles, the trig ratios of angles in a unit circle. We worked out that there are 4 quadrants, first, second, third, fourth, that in the first quadrant all sine, cos and tan are positive. In the second quadrant just sine is positive. In the third quadrant tan is positive, and in the fourth quadrant cos is positive. And we worked out that there are symmetrical properties between the first quadrant and the second, third and fourth quadrants, which are illustrated here, or which are kind of outlined here. So in other words, the sine of 180 minus theta is equal to the positive sine of theta, whereas the cos and tan versions would be the opposite sign. We worked out that the tan of 180 plus theta is equal to the tan of theta, and that the sine and cos versions will be opposite in sign. We worked out that for the fourth quadrant, cosine 360 minus theta would be equal to cos theta, or another way of expressing it is that cos negative theta, which is the fourth quadrant angle, is equal to cos theta, whereas the sine tan versions of both are going to be negative. Okay? We worked out that an angle that goes 360 degrees further around than the angle before it is going to land in the same place and have the same position as xy did, and therefore it'll be equal. So sine 360 plus theta, cos and the tan versions will all equal the sine, cos and tan of theta. We looked at complementary angles. Yep. We looked at complementary angles and we worked out that sine 90 minus theta is equal to cos theta, cos 90 minus theta is equal to sine theta, and tan 90 minus theta is equal to cot theta. Now, cot theta, what is that? Well, we looked at reciprocal ratios, right? We looked at reciprocal ratios. We worked out that cosec theta is equal to 1 on sine, sec theta is equal to 1 on cos, cotangent theta is equal to 1 on tan. We also looked at the fundamental identity, which is really just an extension of the unit circle and Pythagoras' theorem. And we worked out that sine squared theta plus cos squared theta is equal to 1. By dividing both sides by cosine squared theta, we get tan squared theta plus 1 is equal to sec squared theta. Dividing both sides by sine squared theta, we get 1 is equal to cotangent squared theta equals to cosec squared theta. We again looked at the exact values of certain angles which can give us values that are exact. So sine, cos and tan of 0, 30, 45, 60 and 90. We worked those values out and we transpose them onto a sine, cos and tan graph that goes for all 4 quadrants and beyond. Okay, and we worked out that a sine graph looks like this, with a maximum and minimum point of positive and negative 1, starts at 0, ends at 0, and is kind of like a wave function. A cosine graph starts, the highest point and lowest point is 1 and negative 1, and starts at negative 1, starts at positive 1, ends at positive 1, and also is a graph that is kind of a shifted version of the sine graph. And we worked out a tan graph that looks like this, starts at 0, ends at 0, but has asymptotes, remember asymptotes, at 90 and 270 degrees. Asymptotes being lines that act as boundaries that the graph will approach, but never actually reach. And that, my friends, is a great summary of further trigonometric ratios. Okay, encapsulates most of, in fact all of the information that we have done in this unit of work. Thank you very much for watching. I'm going to stand aside now so that you can actually just take all of this in, alright, and you can press pause and take all of this in. But as I said, thank you very much for watching, and hopefully I will see you in future topics, future courses. Thanks.